Hello viewers, welcome back to my YouTube channel. If you're just coming across my channel for the first time, you're highly welcome. Kindly subscribe, like and share. So here is question 2 in linear programming. So I've treated question 1 already. You can kindly check on my YouTube page for the full video. So the question states, a company produces two products whose input and demand requirements are in the following table. So we have this table. So we have the raw materials for product 1 and 2, labor per day, unit per day for product 1 and 2, the demand per unit per day for product 1 and 2, then the profit made is this value, and the maximum resources available for raw materials is 42, for labor is 60. A. Determine the optimal product mix using the graphical method is 13.5 marks. B. Succinctly explain any form of the following linear programming terms or convention. We have the decision variable, right-hand side variable, the contribution coefficient, technological coefficient, then the site or structure or system constraints. So these are 4 marks. For this video, I'm going to only show the computation. Then in the subsequent video, I shall treat the terms and conventions of in linear programming. That is the terms and terminologies that are in linear programming. So in this question, we're dealing with profit. Even without being told, in this question, are we minimizing or maximizing? In my previous video, the question one I treated, what we did was on total cost. And as a business-oriented personnel, when you're dealing with total cost, you will make sure you try to minimize. Hence, that will be the minimization in linear programming. But in this case, we are dealing with the profit here. So we need to maximize it, hence the maximization in linear programming. So this question is about the maximization in linear programming without being told, because if you're dealing with profit here. So I'm going to take you step by step on what to do when computing it. So step one shall be to formulate the above problem into linear programming model using inequalities. So let X represent product 1 and let Y represent product 2. So we have to maximize this Z is called that variable that should be maximized, which is 7 and 9, which is the profit. So to put them into the linear programming equation, that will be 7x plus 9y. So we are subject to. So what are the constraints? The constraints here are raw materials and labor. So the constraints simply means what are those factors that can be that can either hinder the process of production or further the process of production. For instance, now if the raw materials are not in adequate supply, it will slow down the process of production and vice versa. And if labor is not in adequate is not available, it will hinder the process of production or it will slow it down. So subject to, what are the constraints here? We have the subject to raw materials. My raw materials here are 6 and 7. So for us to put them into a linear programming equation, that would be 6x plus 7y, which is less than or equals to 42. We're making use of the less than or equals to because this is maximization. When we are minimizing, the inequality to be used shall be greater than or equals to. But when you're maximizing, the equation to be used shall be less than or equals to. So we have 6x plus 7y less than or equals to 42. This is the raw material constraint. Then for the labor here we have 6 and 12. So to put them into a linear programming equation, that will be the labor here is 6 and 12. So that will be 6x plus 12y less than or equals to 60. So this is the labor constraint. So for the demand, that will be x less than or equals to 5 and y less than equals to 4. So this is the demand constraint, and also the demand constraint for x and y. So we have x and y less than or equals to 0. That is non-negativity, negativity. So this simply means that our product x and product y can either be 0 or greater than 0. They can never be negative. They can either be 0 or greater than 0. That is the meaning of this negativity, non-negativity. So this is a step 1. So step 2, the step 2 shall be to convert the above constraint into an equation. Convert the inequalities to an equation. An equation. So we have 6x plus 7y equals to 42. 6x plus 12y equals to 60. X equals to 5 and 1 equals to 4. Remember this equation is for raw material. This is for labor. This is for demand. And this is also demand. What we have here is the same thing with what we have here. The difference is that we change this less than or equals to signs into an equals to sign. So step 3. For the raw materials, which is 6x plus 7y equals to 42. This is the constraint for the raw materials. So you will substitute x to be 0 to get your y and vice versa. Now, if x is 0, y shall be what? We don't know. So we have 6 bracket 0 plus 7y equals to 42. If x is 0, just substitute x to be 0. So 6 bracket 0, which is this. So 6 times 0, that will be 0 plus 7y equals to 42. 7 equals to 42. So the coefficient of y is 7. So divide both side by 7. So this y becomes 6. So it simply means that if my x is 0, my y becomes 6. And you have to do the same thing to that. If my y is 0, my x becomes what? So we have 6x plus 7. In place of y, I'm going to substitute it to be 0 equals to 42. So we have 6x plus 7 times 0, that's 0 equals to 42. So we have 6x equals to 42. Divide both side by 6. So x becomes what? That will be 7. 7. So this one is for the raw materials. Then for the labor, the equation for the labor is 6x plus 12y equals to 60. So you do the same. If x is 0, y becomes what? So in place of x, I'm going to substitute x to be 0. So that will be 6 bracket 0 plus 12y equals to 60. 6 times 0, 0, that will be 0 plus 12y equals to 60. 12y equals to 60. Divide both side by 12. So this 12 cancels 12, so y becomes 5. So it simply means if x is 0, y becomes 5. And you do the other same way, that if y is 0, x becomes what? We don't know yet. That'll be 6x plus 12. In place of y, that'll be 0 equals to 60. 6x plus 12 times 0, that will be 0 equals to 60. You collect the like term, so that 6x equals to 60. Divide both side by 6. So that'll be x equals to that'll be 10. That should be 10. Then for the other constraint, which is, so this one, This single values x equals to 5, y equals to 4. So you're going to write out your x and y in this way now. Now, for the raw materials, when my x is 0, my y is 6. And when my x is 7, my y is 0. Then for the label, you do the same thing. When my x is 0, my y is 5. And my x is 10, my y is 0. So it's better you write them out this way so that they can be handy. So that when you're plotting your graph, you can easily look at them and know what to do. Then for the demand as well, this one here, this one here, x 5, y is 4, which is what we have here. Demand unit per day 5 and 4. So we will come in handy this way. X equals to 5, y equals to 4. So step 4 shall be to plot a graph. So before you plot the graph, you have to check for your y and your x axis. Check which one. Okay, now for us to um rule like write out the values for our x axis. Check all your x values. The x here. Check the one that is the highest. For my x now, when you look at these values of x, the lowest value of x is 0. When you compare this and this is 0. And the highest value of x between the raw materials, the labor, and the demand here, the highest value is 10. So you should try and make sure that when you are writing out the values for your x, this 10 should be inclusive, which was what I did here. This is my x-axis. You can see I have from 0 to 10, which is this. And for your y-axis as well, we check the lowest value of y is 0, which is this 0, and the highest value of y is 6. Raw materials, labor, then the demand as well. The highest value of y is 6. So you should try and make sure that 6 is included in your y-axis. Now, for the raw materials now, for this raw material, let's start to plot. If x is 0, my y is 6. If x is 0, my y is what? 6. Just asterisk, just put the sign here. When my x is 7, so we are trying to plot the raw materials for the raw materials for now. So if x is 7, y is 0. So if x is 7, if x is 7, if x is 7, my y is 0. So the point of intersection shall be from this 6 here. So this 7 here. So you're going to use your ruler to join from this 6 here to this 7 here. So after joining this line, so this line is for the raw materials. It's for the raw materials. So the next one shall be for the label. If x is 0, my y is 5. If x is 0, my y is 5. This is the point of intersection for that first one. If x is 0, y is 5. So the next one shall be if x is 10, y is 0. If x is 10, this is my x-axis. If x is 10, my y here shall be 0. So it simply means we have to join this 10 and this 5. So the joining of the 5 and 10, the joining of the 5 and 10, this line here shall be for the label. So the next thing to draw is the demand. If x is 5, my y is 4. So if x is 5, my y is 4. So if my x here is 5, which is this, my y here shall be 4, which is this. This is the 4. So the point of intersection shall be, just trace the 5 and the 4 here. This 4 here now, just trace it down here. And this is the 5 for the x-axis. So this place is the point of the intersection. So your graph should look like something like this. So this line here is for the demand. This is the demand. This is for the labor, and this is for the raw materials here. We also need to join this. That is the 4 that is connected to the one of the 5. So your graph should look something like this. So after plotting all your constraint, which is your raw materials, your labor, and the demand, you should have something of this nature. So you have to check your point of your corner point. So this shall be my corner A, this shall be my corner B, this shall be my corner C, and this shall be my corner D. And this side that's my shaded below is my visible region. After plotting your graph and after the intersection, you have to check the demarcations like so. If you have something like this, so the this line is the one that is mostly above. So you have to shade everything that is within that area, like so, to get to your corner point. And here for our A now, our x is 0 and our y is 0. For the B, my x is 5 and my y is 0. For the corner C, my x is 5 and my y is 4. And for my corner D, my y is 4 and my x is 0, which is what I have here already, the corner points A, B, C, and D. And this is what we're maximizing, which is the profit, which is from this question here. So step 6 shall be to compute for our solution table. So your solution table shall be of this nature. We have the corners, the x, the y, the contribution, which is this, and the contribution product mix. So you have to put your x and y I got it from the graph. So we have something of this nature. 0, 0, 5. For C, we have 5 and 4. My x is 5, my y is 4, and for D, like that. So you start to substitute 7 brackets. If my x is 0 and my y is 0, when you do 7 times 0 plus 9 times 0, that is 0. Here, we have 5, our x to be 5 and our y to be 0. So let's do it together. We have 7 in the brackets like this. We have 7 times 5 plus brackets plus open brackets again. We have 9 times 0. 9 times 0 plus your brackets. So you're going to have 35, which is how we arrive at this 35. Let's go for corner C. That will be 7 times 5. Then this is 9 times 4. I'll just change the 0 to 4. That'll be 71. So that's how we got this to 71. Now you do the same for the others. So this column means contribution and it is also called the profit. But that's what we are maximizing. So the highest value here is 71, which is at corner C. So that's why we have that the highest contribution is 71 naira at corner C. Look, that when you are maximizing, the visible region shall be below. And when you are minimizing, the visible region shall be above. Now, because we are maximizing this question, that is why our visible region, which is the shaded part, is below this side. And in the first question I saw, that is on minimization, the visible region was shaded above, which is of this nature. So that's what case. If you don't forget to subscribe, like, and share. Thank you.